Hi, this is Paul Morin with the Energy Conservatory, and welcome to our webinar titled Using the DG1000 with Our Devices. And we'll go over a few housekeeping items first. If you're having trouble with your audio, click on Meeting in the main navigation menu and choose Audio Setup Wizard and follow those steps. If you're joining Adobe Connect, the Adobe Connect app on a mobile device, you'll need to use your external speakers or headphones to hear the audio. Please type in questions in the box on the right as you think of them, and we will be typing in responses as we go along, and also we'll do a question and answer session at the end. This webinar, as all our webinars, is being recorded and will be available on our website and our YouTube channel soon. You'll be able to find a number of different recorded webinars on our site, and you can watch those at any time. And we're always looking for input on what type of webinars you'd like to see, and we value your input on that. If you're looking for BPI continuing education units, for this webinar, available attendees will receive 1 credit. And we will upload the data to BPI, and the CEUs are awarded by BPI after the completion of the webinar. So we don't give out certificates for completion, but it'll go through the normal process and you'll see those credits show up on the BPI site. If you didn't provide us with your BPI number when you registered, you can still email us at editor@energyconservatory.com and include your full name and BPI numbers, and we'll make sure you get those credits. But to receive credits, you must be logged into the webinar under the name you registered under. So you can't watch a webinar along with somebody else on their computer and expect to get a credit. You need to be logged in, you need to be registered and logged in under that email address to get credits. If you're having technical difficulties, it's best dealt with by Adobe Connect, and here's their phone number, and select the option in meeting support, and we've had really good luck with them dealing with those technical issues if it's on their end. We have had some audio issues in a previous webinar that wasn't related to them, but generally speaking, you're best off contacting Adobe Connect directly if you're having troubles. And if you do need to call them, we'd like some feedback on that issue to make sure that those things get resolved to make this experience more pleasant as we go forward. So our agenda for today, we'll start out with an intro to the DG1000 for those of you who aren't familiar with it, and then we'll go over using it with the blow-at-air duct blaster and TrueFlow. So the first step will be to power it on, and the power button is recessed, so it's unlikely you'll turn it on or it will turn itself on. And you'll hold that button down till you see the starting sequence start, and until you see the power indicator light come on. And currently our boot up time is about 40 seconds, so it does take a while for it to boot up, but we're planning on we're working on that, so in future releases that time should get better. And this is the home screen. When you first boot it on, the home screen will come on, and currently we have four apps on that home screen, and we will be adding additional apps over time. So the 4 choices are power off, to turn the gauge off, so you can use either the on-off button, or you could choose to turn it off from this location. And then the gauge settings screen, the gauge updates screen, and then the gauge app. And when you choose the gauge app, then this is the screen that will come up. So we'll do an overview of this screen that you see, and then we'll get started. So this is your gauge's serial number, and to get back to that home screen that shows the apps and the gauge settings and the network screen. So this will show what if you have any of the networks turned on, such as Wi-Fi, or if you've enabled the USB cable or the Ethernet cable. And the battery level is displayed there. We do have speakers, so it will make sounds, and it'll make beeps just like the DG-700 did. And basically that's whenever you're telling it to do something it can't do. An example of that would be if you set it to cruise 50 and it's giving the controller 100% power and it's not up to 50 yet, it'll start beeping at you telling you I can't do that. The cruise target, the device configuration, so which ring setting you have, the flow device you've chosen, the flow device that you're using, and the mode, pressure flow at 50, etc. Setting your baseline, and the fan control slider, and time averaging. Okay, so let's get started. In this session, we're going to show using the DG1000 for a blower door test, and we're going to do both a depressurization test and a pressurization test. And for a pressurization test, we're going to need to connect an extra tube to the reference on channel B, and we're going to need to turn the fan around because we're going to be using it to measure flow. If you have a reverse switch, that's fine for pressurizing the house, but you can't have the fan that way for measuring flow. So you have to physically turn the fan around. So this is what our fan will look like once that's turned around. So let's switch to the gauge. Let's take a closer look at the gauge here. Okay. So you can see we've got the gauges turned on, and we're showing the home screen of the DG1000. And we've got the fan control cable connected to the top of the gauge here, and then to the speed controller, our fan control cable. And currently on the home screen of the gauge, we've got 4 apps. So this is a home screen, and these are referred to as apps. One is to power the gauge off. Another one is the gauge settings, and then for updates, you would choose that one, and then our gauge app. So we're gonna choose our gauge app there, and this is showing our DG700. So it will come in. It will open up in whatever settings you last used on the gauge. So in this case, you can see our mode is set to flow, or CFM at 50. And when you're in the flow CFM at 50 mode, you'll be able to see all of the devices. So if I go to the mode screen, if I touch on that flow there, we'll be able to see all of our devices. If we're in the pressure flow mode, now I push the device key, and the device button up here in the middle. So we've got mode and then device configuration. So when I choose the device key, we now see all of the selections. We see the Model 3 fan, the Duct Blaster fan, Model 4 fan, Model 3 220 exhaust fan flow meter, the TrueFlow, and the micro leakage meter. So that's if we're in the pressure flow mode. But if we're in the pressure flow at 50 mode, all of those devices won't show up because you'll never use the exhaust fan flow meter in the pressure flow at 50 mode. So they won't show up. Those other devices like the TrueFlow and the exhaust fan flow meter won't show up in the pressure flow at 50 mode. So, but we're going to be doing a blower door test. So I clicked on the mode there. We'll set it to pressure flow at 50. And our device is the blower door. And we're going to change the configuration to ring A. Okay, so then we'll click back here where it says channel B configuration. We'll go back to our previous screen. So now we're set up to do the blower door test, and you'll notice the cruise default is 50 pascals for I shouldn't say the default. It was last used in the pressure flow at 50 mode. So if you had done a duct blaster test last, the mode will be still at pressure flow at 25. So that's our cruise feature there. So now I'll take a baseline reading, so you can see it says set baseline here, and I'll choose that. And now it's counting up in seconds. Let's see if I change this to 2 times there, we can get a little better view of the screen there. So now we're counting up in seconds, and this is staying pretty stable now. So I'm just going to push enter here, and that entered our baseline in there. And you can also see our tubing connection. I didn't cover that before, but we've got input and reference here. So we're connected to on the DG-1000. If you're used to that, the input is on the top, reference on the bottom. So we think of this as house with reference to outside. So instead of top bottom, it's left right. So we've got our reference tube, our green tube going to the outside, and then our input tube going to our fan on channel B. Okay, now I'm going to uncap the fan. And I'm going to use the cruise function of the gauge, but you can just grab the slide bar and pull it across too. So I'll click the speed controller on, so we can either ramp it up to 50 this way, or we can simply hit the cruise button there. And when we hit the cruise button, we see that the stop fan button shows up here. So now it's going to start ramping up to get us up to 50 pascals. Okay, so we're right around 50 now. So our CFM at 50, we're at about 1775 or so. If we want to, we can use the long-term average. So I can hit the average here, and we can choose long-term. And then over time, this number will become a little bit more stable. So we can see that settling down a little bit. It's a little bit windy today. So we're settling down at right around 1777, 78, 79. Still fluctuating a little bit. So we can call that, we'll call it 1780. Okay, then we'll stop it. And now we're going to turn the fan around, and we'll use the same baseline. I'm going to turn my averaging here back to 1 second, and we'll keep that baseline in there. And we see the baseline was negative 0.7, so that's the baseline. It zeroed out. So now I'm going to turn the fan around, and we'll connect extra tube, and we'll do a pressurization test. So I'll turn the fan around. Okay, we have the fan turned around, and channel B is reading the pressure at the flow sensor of the fan with respect to the location that flow sensor is in, with reference to location that flow sensor is in. And the flow sensor is on the inlet side of the fan, the side with the rings on. So now that side of the fan is outside. So we need to connect an extra tube to the reference on channel B when we're doing a pressurization test with the gauge inside the building. So now we've got all our tubes set up. So we used the cruise 50 last time. So this time I'll just use the slide bar to ramp it up to 50. There we go. So you can see we're a little bit leakier. I'm going to go to long-term average here again. We're a little bit leakier in the pressurization mode. We're about 1780. Now we've blown some dampers open. The kitchen fan, bath fan, clothes dryer. Dampers have blown open, so we're a little bit leakier. So we're right about, a little over 100 CFM leakier in the pressurization mode. So now we'll stop that. Okay, so that's it for using the DG1000 for a blower door test. So in this session, we're going to do a pretty straightforward test. We're going to do a duct blaster test using the DG1000, and we're going to do a total leakage test, total leakage pressurization test. So let's take a look at the DG1000 gauge. And you can see that we've got a newer Minneapolis duct blaster controller. and that has an on-off switch. It's a little larger, and it also has a jack for the fan control cable. So we're running that fan control cable up to the tap on the DG1000. It plugs in the top of it there. This version of the DG1000 has 4 apps on it currently. So when you turn it on, you come to the home screen, and it's showing 4 different apps. We've got the power off, the settings, the updates, and the gauge. So let's go to the gauge. That brings us to our gauge, and you can see that we've got some labels at the bottom: input reference channel A, input reference channel B. So it's and we've got a green tube going to the duct to supply register. So we've got duct with reference to the house. So instead of being top bottom, it's left right, duct with reference to house. And on channel B, we've got the flow sensor on the input with reference to the house. So that's our tubing connections. Let's zoom in here a little bit so we can see the gauge a little bit better. And focus that a little bit. Okay, yeah, that doesn't look too bad. So we can see our cruise setting is set to cruise at 25. We're set in the pressure flow mode. We've got the duct blaster or blower door fan, Model 3 fan, and we're set to open. So it's good practice to start with the mode button. We're set in pressure flow, and because we're in pressure flow, all of our devices will show up, like the exhaust fan flow meter, for example. Wouldn't show up if you were in the pressure flow at 25 mode, so that can get a little confusing. So it's best to set up the mode first. And another example, if the device was set to exhaust fan flow meter, so if your device was set to exhaust fan flow meter here, the only mode that would show up is pressure and flow, because those are the only 2 modes you would use with the exhaust fan flow meter. So it's good practice to avoid confusion to start with the mode button. So we're going to change the mode to pressure flow at 25, and then we'll move over to the device and we'll change it to duct blaster fan, and then we'll move over to configuration and we'll change it to ring 1. So it gives you a new menu every time you choose one of the pull down menus. So then we're gonna you can see the arrow here, and that brings us back to the home screen. So any of these things that show the little triangle next to them are things you can touch and change on the screen. So now we're all set up to do our duct leakage test, and we'll turn on the speed controller first, and now we can control the fan speed 3 different ways. I can use the knob, the controller knob, and you can kind of see my hand here on the knob, and we can turn it up that way, or we can use the slide bar here on the gauge. If you want to turn it up that way, you could do that, or we can set it to cruise. And because I've got the cruise control cable and we've got that set up, my hand won't be in the way, and you can see it just ramp up the pressure. And once you start getting close to 25, because we're in the pressure flow at 25 mode, this number won't change very much. So you don't have to be right exactly at 25, because your reading is only going to change by a Pascal or a CFM or so as you get closer. So we're at about 440, and then I'll push the off button here and turn it off, and that's really it for our duct blaster pressurization test. In this session, we're going to do a duct leakage to outside test using the duct blaster fan and 2 of the DG1000 pressure and flow gauges. And we're going to set this up in the blower door in pressurization mode. So we're going to turn the fan around. If you have a reverse switch, this is a good application for that. You can simply flip that reverse switch and be blowing air into the house, pressurizing the house that way. If you don't have the reverse switch, then you'll have to flip the fan around, so the air is coming into the house for the duct leakage to outside pressurization test. So we've got both the blower door fan and the duct blaster fan set up to pressurize the ductwork and pressurize the house. Now we'll take a look at the gauges. There we go. And now we'll get a full screen picture of those. So on the left side, you can see we have, let me get our focus here just a little better. Okay, there we go. And I'm gonna, you'll notice the new gauge boards that come with the DG1000 gauge have little slots where you can connect the tubing to kind of get them out of the way, and we're using that on this gauge, and I'm gonna click that in on this first one here, so that tubing is kind of out of the way and set up a little better. All right, so you can see we've got our blower door speed controller on the left side here, and we're set up house with referenced outside. So the green tube going to the reference on B is going outside. And then our duct blaster gauge, you'll notice this is a newer duct blaster controller. They're a little larger. They have an on-off switch on it here, and you can also use the cruise feature. It's got a fan control cable input, so you can set it to do cruise or do automated testing using the duct blaster fan. Sometimes the duct blaster fan is used as a blower door, and so you could do some automated blower door testing using the duct blaster fan. So the gauge has a fan control tap, so we've got our fan control cable plugged into the blower door, and the gauges are turned on. When they're turned on, it brings you to the home screen, and we've got 4 different apps on there, and we're gonna choose the gauge app for both of those to get us into the gauge screen. So we'll set up the blower door one first. You can see we don't have any tubing. We're not measuring flow during this test. We're just using it to pressurize the house. So I'm going to change the, instead of being flow at 50, I'm going to change that, and we'll just change channel B to pressure. So it's less confusing that way. We're actually not using channel B at all. So that'll just stay reading 0.0 there. We've got a little bit, our fans are capped and ready for our baseline. So we'll set our baseline here. And now we're starting to count off on channel B. And the way I do it is usually if the number on channel A is now displaying a moving average, and if it looks like it's pretty calm out there today. If that moving average stays the same for a few seconds, then I'll go ahead and push enter. Looks like we got the wind picking up a little bit, but it's staying at 0.6, so I'll push enter. Okay, so now that cleared out our baseline, and we're seeing that our baseline was negative 0.6. So that's a new feature, is it shows you what the baseline was, how much it subtracted. How much it's subtracted from your when it entered that in. So now I'm going to go, and another thing, what I did for this test is I capped both the blower door fan and the duct blaster fan for the baseline period, and you know, you can see we've got real steady pressure, so I didn't enter a baseline in on the duct blaster gauge because we don't have a baseline. But there may be situations if you've got a lot of ductwork outside that that you'll have kind of a moving target for your ductwork baseline. But the ResNet standard does call for you to cap both the blower door fan and the duct blaster fan during the baseline period. So that's how I set it up. So now I'm going to uncap both of those fans, and we'll start the test. In this house, our ductwork is in the basement, and our blower door set up on the first floor. So now we're uncapped. So now I'm going to set the baseline. And actually it's set to cruise 50, so I'm going to change that cruise to 25. Hit the start cruise button. Turn on our blower door gauge and our duct blaster gauge. Our controller rather, turn on the speed controllers. We can see we're up around 25 now, and we can see on our duct blaster gauge we've got a negative number, so we're plus 25 in the house, and our ductwork is less positive than that because it's connected to the outside, so we're seeing a negative number, and we want to be set to the pressure flow mode and not the pressure flow at 25 mode, because if we're set in the pressure flow at 25 mode, it's converting the flow. It's not reading the flow through the fan. It's converting the flow to a flow at 25, and we can't do that at a pressure less than 5 pascals. So if channel A is reading 0, we won't get a reading on channel B. So we need to be in the pressure. We need to be in the pressure flow mode. And we're set to ring 1. We've got ring 1 on. So I'm going to turn up our duct blaster controller until we get to oops, I've got ring 3. Actually, I've got ring 3 on. Got ring 3 on our duct blaster fan. That's better. So I'm turning up the speed to get us at 0. So we can see we're right at put it back to 0. Right at about 43 CFM duct leakage to the outside at this one. And our pressure on channel A is fluctuating around a little bit, but we're still staying at right around 25 and right around 0. We're getting a reading of 43, 44 CFM. Okay, so that's our test. In this session, we'll be talking about using the TrueFlow air handler flow meter along with the DG-1000 to measure the total system air handler flow. In other words, when we have the air handler turned on, what's the total amount of air moving through that system? In our basic test procedures, with the air handler on and the filter in place, we're going to measure the normal system operating pressure. And then we're going to replace that filter with the TrueFlow plate. And then we're going to measure the new pressure with the TrueFlow in place. And it's likely that the pressure is with the TrueFlow is either going to be less or more than the pressure with the filter in place, depending on if the filter is more or less restrictive than the TrueFlow plate. And then we'll use the TrueFlow plate to measure the airflow through the TrueFlow plate. And then we're going to use a chart to find the correction, the flow resistance correction factor. And so we're going to record the normal system operating pressure. We're going to record the TrueFlow system operating pressure. And then we're going to use those two numbers on a chart to calculate the flow resistance correction factor. And that correction factor will be used to adjust our flow. So then we'll be able to have a flow, a number of what the flow would be with the filter in place, right? That's what the flow number that we want. So this correction factor will adjust the flow we measured through the TrueFlow plate, so it would show what the flow would be if the filter was in place. And for measuring the pressure, the normal system operating pressure and the TrueFlow system operating pressure, we'll need to be using a static pressure probe. And this comes with the TrueFlow plate. So it's got a magnet on it that will help hold it to the plenum. It's got a 90-degree bend. We want to point that in the direction of the airflow. And it's got a sealed end on it and 4 tiny pressures. So it's measuring the static pressure in the duct. And we've got a few locations and restrictions on where we can put that static pressure probe. Most often, and what we would say is the best location is the side of the supply plenum, or it could be in a dead-end corner of the supply plenum. It could be on the side of a return plenum that doesn't have a trunk line coming across it. So if you've got an upright air handler and you're standing facing it, and the trunk line is going away from you and towards you in that direction, then you would put it off on the side, either the left or right side of the return plenum. Or you could put it in a return register or a return duct that's connected to it. The static pressure probe needs to be 24 inches away from the location where the TrueFlow plate is. It needs to be 24 inches away from any 90-degree turns, any 90-degree corners, and 24 inches from any return trunk line connections. So if you've got a main return plenum and there's trunk lines going off of that, you need to be 24 inches away from where any of those connections are. If you're installing the TrueFlow plate at a remote filter grill, if you've got one central return for the system, you can locate it there. If you have two return system, then you'll need to use both of the TrueFlow plates, and they'll both need to be in place when you're taking the measurement. That's kind of the overriding factor of this to get an accurate measurement. All of the return airflow needs to be moving through the TrueFlow plates at the same time in order to get an accurate measurement. So you always need to keep that in mind, that all the airflow needs to be moving around those filters. I mean, none of it can be moving around the plates. And if you're connected at a remote filter grill, don't put the probe in the return side. Then you'll need to have that probe installed on the supply side. And here's that normal system operating pressure and TrueFlow system operating pressure chart where we can calculate the flow resistance correction factor. And you can see on this chart, and this is in the TrueFlow manual, and you can see on this chart, if we look across the top, this is the normal system operating pressures across here. And there's actually 4 different charts to choose from. And this chart is in pascals, and it goes from 50 up to 150. And the other chart goes from 0 to 50. So depending on where your normal system operating pressure and TrueFlow system operating pressures fall, you'll choose which chart you want to use. If you want to use inches of water column instead of pascals, you'll use a different chart. So you can see, so normal system operating pressure is going across, and the TrueFlow system operation pressures are going down. And then you'll find where those two meet. So if one was 70 and one was 65, you would go 70 and follow it down to 65, and 1.04 would be your resulting number. And if you want to get, and these go in increments of 5 pascals, if you want to get a little more precise, you could use this formula where you take the normal system operating pressure, divide it by the TrueFlow system operating pressure, and the results of that, you would take the square root of that. And that's how these are calculated. So let's take a look at the DG 1000 gauge. And we'll expand that a bit. So when you first turn on the gauge, this is the screen that will come up, and you can see there's 4 different apps on here, and we'll be adding more apps over time. So the power on, settings, update, and the gauge screen, the gauge app actually is what we'll be using. And you can see our tubing connections here with the DG-700. You can see the input and reference labeled here, and it's left right instead of top bottom. So when you're doing a blower door test, you're measuring house with reference to outside, and it's left right instead of up down. So our tubing connections here on the input, we're measuring the pressure in the supply plenum, the normal system operating pressure, using a static pressure probe. And then on channel B, we're measuring, there's 2 tubes coming off of the TrueFlow, a red and a green, and we're connecting the red to the input and the green to the reference. And I'm showing longer tubes here because I've got these tubes leading back to the air handler from where I'm at, but the TrueFlow just has small, about 2 or 3 inch pieces of red and green tubing that are connected to a smaller diameter clear tube that are taking the measurements off of the plate. So but with the DG1000, it's looking for the tubes to be connected in a specific order. So the polarity matters. So the red tube needs to be connected to input, and right tube needs to be connected to reference in order to get a reading. Otherwise, it won't give you a reading. Okay, so now I'm going to turn on the air handler with the filter in place. And we've got our static pressure probe in the supply plenum. And our number is moving around a bit, so I'm going to choose change the averaging period here. You can see here's our time averaging. We're at 1 second, and I'm going to change that to long term and just let those pressures even out a bit. Okay, so we're at kind of bouncing around just a little bit. We'll call it 54.7. Okay, 54.6. I'll change the time averaging back to 1 second. 54.6. So we'll write down that number, and that's our normal system operating pressure number. Now let's set up our gauge. So we've got it set up for measuring the TrueFlow, and I recommend always choosing the mode first, because, for example, if we have it in the pressure flow at 25 mode, like we have it set now, the TrueFlow won't show up as a device because you can't measure the TrueFlow, the correct TrueFlow readings being in the flow at 25 mode. So we need to change this to the pressure flow mode so we could even choose the TrueFlow. So we're going to tap on that, and that brings us to this screen, and we'll choose flow. And then for device, we'll choose so now when we're in the pressure flow mode, all of the devices will show up. We'll choose the TrueFlow there, and then we're using the number 20 plate. The 14 plate is 14 by 20, the 20 plate is 20 by 20, so that's pretty easy to remember which one's which. We'll choose the number 20 plate, the bigger one, and then we'll go back up here in the corner where it says channel B. We'll hit that back arrow, and that'll get us back to the gauge screen. So now I'm going to switch. I'm going to turn the air handler off, put the TrueFlow in place, and we'll get our TrueFlow system operating pressure. Okay, now we've got the TrueFlow in place, and that's turned back on. So I'm going to choose long-term average here a little bit, just to let these numbers average out. So right now, channel B here is showing what the flow is through that plate, through that TrueFlow plate, and we'll record that number. That's 801, and our TrueFlow plate number is 57.9. Okay, and we'll set that back to 1 second average. And we'll turn the air handler off. Okay, so now we'll look back at that chart. All right, so we had a flow of 801, and the TrueFlow system operating pressure was 54.6. So we'll go to 55 here, and then we'll move down to 58, 57.9, 58. So we can extrapolate a little bit between 96 and 1 and say it's point, we're really close here to being just 1, to not having to make the adjustment, because the change in pressure is pretty slight between the filter and the TrueFlow. But the TrueFlow was a little, let's see, let's say we'll go 0.98. So we'll take 0.98 times 801. That's 0.98 times 801. And that gives us about 769. So so the 801 was the flow through the TrueFlow, but the flow through with the filter in place would have been 769. So that's how you use the TrueFlow with the DG1000.